graph transformations. There are 4 key graph transformations that you'll be asked to do at Core 1. Now, in an exam, they give you a question often like this, where it shows you a diagram of y equals fx with a couple of points identified on the graph. And what they want you to do is they want you to draw a quick sketch, separate diagrams, for what happens when you do y equals minus f of x. And they want you to identify what would happen to these key points here. So, what would happen at 3 and what would happen at x equals 2. So, let's go back to the top and look at what the 4 different graph transformations are. Sorry about that. Right, firstly, the easiest one is fx plus a. Now, all this does is this plus a just makes the graph move upwards and down the y-axis. So, if it's a positive a, it moves up the y-axis. If it's a negative a, it moves down the y-axis. AF of x. This stretches the graph in the y-axis by a scale factor of a. So, just think of y equals x squared. And say you put 2 in. So, it'd be 2 squared, which is 4. But then you change next time, you want to plot 2x squared. Well, 2 squared is 4 times 2 is 8, which stretches it in the y-axis. So, there's our second graph transformation. So we've got the first one, the fx plus a, which moves it up and down, and the second one, where the value in front, it stretches it in the y-axis. Next one is f in brackets x plus a. Now this one always confuses me in my head, because when it's plus a, I always think it should go to the right, but it doesn't. If you're adding a value of a, it moves to the left. If it was to subtract a value of a, it moves to the right. So you've got to remember that. If it's fx plus a, it goes to the left. If it's fx minus a, it moves to the right. And the final one is f in brackets ax, which stretches the graph in the x-axis by a scale factor 1 over a. So, just make it wider or narrower depending on what the value of a is. Now, you need to know these 4 graph transformations. And let's look at an exam question on these 3 questions. So, firstly, it says the diagram shows part of the graph of y equals fx. On a separate diagram, sketch the graphs of y equals minus fx. So, firstly, the minus. So it's the function times by minus 1. Now what that means is it reflects this through the x-axis. So, quick sketch. So here we go. Y, x. So the value of 2 is going to stay where it is. But now instead of crossing at 3, it's going to cross at minus 3. And you need to draw this graph the other way around. So instead of going from bottom to top, it's going to be this way around. And it's a quick sketch, and we've identified those 2 key values. Right, next one. It says f of x plus 4. Now remember, because it's plus 4, it moves 4 places to the left. Now, our new diagram is going to be something along the lines of this. Now, we no longer know where it's going to cross the y-axis because it's moved away 4 places to the right. So, the only one we know is this 2 is now moving 4 places to the left. So, instead of the bottom point being at 2, it's going to be at minus 2 because 2 take away 4 is minus 2. So, this is going to be at minus 2 and it's going to look something like that. So, we just need to label y and x and it's a quick sketch. The next one, y equals f of x minus 2. So remember, when it's a plus or minus on the end, it just shifts it up and down the y-axis. So it's minus 2. So if we look at our original diagram, we're going minus 2. So we're moving this whole graph down 2. So instead of crossing now at 3, it's going to cross at 1. So it's going to cross at 1. We no longer know where this point's going to be anymore. So it's going to look something like this. And the final one is very similar to the first one, y equals 2f of x. So this means it's going to be stretched. So it's going to be stretched up the y-axis. Now, as this value here must have been 0, that's going to stay where it is, because 0 times 2 is still going to be 0. But this value here, instead of being 3, it's now going to be twice as big, so it's going to be 6. So we can label a couple of points on this diagram. So we've got our y and our x. So instead of going through 3, it's going to go at 6. It's still going to go through 2, and it's going to look something like that. Now, as I said, make sure you label on any key points you can on your diagrams. So you need to know these 4 graph transformations. So fx plus a moves it up and down the y-axis. F of x stretches it in the y direction. Fx plus a, remember, if it's a plus, it moves to the left. If it's negative, it moves to the right. And finally, f a of x stretches it in the x direction by a coefficient of 1 over a.